All right, guys, last section of the entire semester. Yay. We're in 8.4. Your homework is 1 through 19 odd. First off, let's remind ourselves of what everything represents. A is the accrued amount in the account, whether it's the total that you're going to pay on your loan or the total amount that you have amassed if you have invested somewhere. Principal is what you started with. R is your interest rate. Remember to write that as a decimal when you plug it in. T is time in years. And now the new thing, we're compounding this interest in times per year, okay? So that means like your credit card, whatever you owe at the compounding time, they'll take that 12th because the rate is in years, but they compound your credit card interest every month. So they'll calculate how much the 12th of that interest that you owe for what your outstanding balance, and they add that to your outstanding balance. Now, if you're looking at a savings account, they'll take the amount of money in your account, find 1/12 because it's monthly, find 1/12 of the interest for that amount for a year, and then add that back to the amount that you owe or that you've accumulated. So think about this. Your credit card, they're compounding what you owe them for in interest every month and adding that. So if you don't pay that off the next month, they're going to be calculating interest to charge you on the interest that they have charged you that you haven't paid off. So things grow faster when they're compounded more often. Okay? It's great when somebody's paying you, but when you're making payments on a loan, you have financed a car or something like that, it's not so great in that case. Okay, so yearly is done one time a year, semi-annually is twice a year, quarterly is 4 times a year, monthly, this is the one that you usually run into because it's easiest, is 12, easiest to keep track of. If it's compounded weekly, that's 52 times a year. Daily is 365. You get the point. Okay, for an example, let's say that you want to buy a $30,000 car. At 4%, you want 5 years to pay it off. They're going to compound your interest monthly. Okay, so you're finding a $30,000 loan, 4% APR for 5 years. This is the kind of thing you see in an ad or whatever, but it's compounded monthly. So the structure of this equation, here's the interest rate. That's an annual interest rate, but you're compounding it every 12 times a year. So you're going to take that annual rate and divide it by the number of compounding periods. There's your R, there's your N. And when you add the 1 to it, it just means you're at the principal plus the interest, except you're doing this every month. So you've got to raise it to the power. This power ends up being the total number of compounding periods for the life of the loan. So there's 12 times in a year for 5 years. They're going to do this 60 times over the life of your loan. So your job is to learn how to plug this into your calculator, and it's not so easy. So I've given you the steps here. Look at your calculator and find these buttons. You know divide, you know add, you know equal or enter. It's at the bottom. You need to look for this. This is called a caret key. This is what is going to take this number and raise it to a power. So some calculators have this upside down V, and some have x to the y or y to the x. You're going to be putting in your base, hitting this button, and entering your exponent. Once you get this done, notice that after you add the 1, you're going to divide first, then add. You have to hit enter. If you don't, you'll just be raising 1 to the power. You need to calculate the entire parentheses by hitting equal, then you hit the caret key, then you plug in your exponent, and you'll need to have multiplied this out first, and write it down. So you put that in there, you have to hit enter or equal again. That will calculate the parentheses to the power. And the last step is the multiplication. Remember order of operations, that's all we're doing. We're going inside the parentheses. We're doing division before we do addition. We have to calculate that by hitting enter. Then we do the exponent before we do multiplication. Okay? So if you follow these steps, I want you to practice it. Stop what you're doing, pause the video, get your calculator, try plugging this in, and make sure you get this answer. Now look at what this answer means. You started with 30,000. At the end of 5 years, it's 36,629.90. So you see that we've added $6,629.90 in interest. The more often you compound, the more money it is, okay? Now compare this. Simple interest from the last section is calculated once for the whole 5 years. So it was just 1 plus the 0.05 times the 5 years, and calculate that out, it was only 36,000. So going monthly has added 629.90 to that bill. Okay, again, the more frequently the interest is compounded, the more interest is earned. So let's use the same parameters here, 30,000 at 4% for 5 years. If we compound yearly, that's once a year, all right? So you have your interest rate divided by the number of compoundings in a year, raised to 5 times 1. Once you plug this in your calculator, stop the video right now and do that, and make sure that you get this value right here. You'll notice that simple interest was just all zeros. Monthly was $629.90. If it's only once a year, it's $130 less. Okay, so the more often you compound, the higher it goes. If it's done weekly, this is just what we did in the last page. If it's done weekly, then 4% gets divided by 52 weeks. Add the 1 and hit enter. Then you should have already multiplied out 52 times 5, which is 260. So you're going to, once you hit enter here, hit the caret key and 260 and enter again, or equals again. Then you multiply by the 30,000 to get this value. Now, let me say something. If you divide this, you're going to get a decimal that's 3333 forever and ever and ever, okay? So this number would be 1.00, I can't remember, 3333 forever. If you truncate that decimal and write it down, say you give yourself 2 or 4 or even 8 decimal places, you're not going to get the right answer, okay? Your calculator is very sensitive, and we're working with tiny differences between this guy in these parentheses and this guy in these parentheses and even this guy here, and raising them to powers. These values inside these parentheses are very, very close to 1. If you truncate that decimal before you raise it to the exponent, all of your answers are going to be close to being the same thing. You cannot do that. That's why I told you on the last page, you follow the steps that I gave you, because you don't want to write down and then re-plug in the value that you get in the parentheses. You want to keep it in the calculator. That's why you don't just type this equation in and hit enter, because you're going to screw it up, I promise. So do the division, don't erase it, add the 1, hit enter, don't erase it, raise it to the power and hit equals, don't erase it, times the 30,000, and you'll get an exact answer. Now we truncate the very last answer to 2 decimal places because it's dollars and cents. But if you're not keeping these values in your calculator, you will not get the right answer. You could conceivably get the same answer for all 3 of these questions because you ignored the last decimal places. So don't do that. Okay. So look at these numbers. Simple was 36,000. When we did it once a year, that's only 5 times total. We ended up giving ourselves almost $500 more here. When we did it monthly, it was up even more. When we do it weekly, it's up another $10, not quite $10, but still it's more. When we do it daily, the 0.04 gets divided by 365 days, and the 5 years gets multiplied by 365 days. This account is getting compounded 1,825 times. So it makes a difference. Now, the money is not that much different than weekly, but it still is greater. And there's an even better way to do this. And the differences are so small that sometimes it just pays off to use the next formula that's coming up. Sometimes it's just easier to do the calculations by doing continuous compounding. Here's the formula. A is the accrued amount or the future value. P is the principal or the present value. This letter E, this is called the natural number. Some of you have seen this in a chemistry class maybe, or in some kind of science class. It's also used a lot in finance for what we're about to see. It's approximately 2.71. And on your calculator, you'll look for the LN key. Find it now. Find the LN key, and you'll see above it in a different color is e to the x. This e to the x is what you're going to use. And because it's above the number, you're going to either hit an inverse or shift or second button. And a lot of times they're color coded. Whatever color that e to the x is, your second button or your inverse button will be the same color. And that's how you know to find it. So you're gonna say P, you're gonna put in the value, you're gonna hit the inverse LN to get the E, and then it's gonna ask you for an exponent. You need to have already multiplied out the RT. You can do it without having multiplied it out already, but it's easier to just multiply out the RT and write it down, okay? So 0.04 times 5 gave me 0.2. I wrote that down. So for the same numbers that we had before, I've got my principal, and I write down E. The R is 0.04. Never use that percent. You always make it a decimal. So you're making it smaller by 2 decimal places for 5 years. So I'm going to plug in the 0.04 times the 5, calculate that, and write it down. And now I'm going to say 30,000 times, I'm going to hit the second or the shift key, and then the ln, which is going to give me the e to the x. It's going to open parentheses for you to put in the power. Your power you already calculated to be 0.2. Hit the enter key and you get your answer. Okay, and you see that this is a little bit more than the daily, not maybe by less than $1, but still it's close. Let me say something real quick before we move to the next page. If you have an older TI-30, or if you look at the calculator on the iPhone, and I don't recommend that you use that even though it's the best one, just saying. If you're using an iPhone or an old calculator, and you can check this by hold the phone. You can check your calculator and find the square root key, or it may be above It may be above this x squared key on most calculators. So you'll do the shift, you'll do shift x squared to get square root. Plug that in, and if it just comes up 0, then you have a different kind of calculator from what this is right here, okay? Some calculators, you put in the function and then you hit the value. An old TI-30 or your iPhone, for instance, you're going to put in the value and then hit the function. So the way to do it, you can put in, say, write down a 4 or punch in a 4 and then hit the square root key and see if it pops up as a 2. If it doesn't, try putting the square root key first and then the 4 and then hit enter. If it gives you a 2, then you're going to do these problems this way, okay? If you plugged in the 4 first, you're saying, I have a 4, take the square root, and the answer will pop up too. That means that you're going to do this in a different way, okay? I'll write out those instructions in green. You need to have checked before, pause the video, check your calculator, doing what I told you, and see what you get, okay? If your calculator is the type that you plugged in, sorry, I'm trying to point here, you plugged in the 4 and then hit the function and got the answer, then this is how you're going to plug in this problem. You're going to say 0.04 times 5 equals, then you're going to hit the e to the x key. I like these calculators better. Once you hit the e to the x key, it calculates e to that power. Then you're going to say times 30,000. Okay? So, the backwards calculator, or the good calculator that I like, personal preference, works this way, to where what it's doing is you're putting in the power and you're saying take e to that power. You just hit the e to the x and it calculates the whole thing. The only thing you have left to do is multiply. So you need to know what kind of calculator you have, know how to use it before you take this test. And the test is coming up. This is the last section. So you've got to learn how to use your calculator. Now, I don't usually ask any questions about this on the test, but it's good to know. Notice that I took the other formula, which was A equals P times parentheses R to the n-t. All I did was divide both sides by the parentheses to the power, and that gives me this. So if I need to know how much, if I know how much I want, and I know how many years, and I know my rate, and we're going to assume for the most part 12 compounding periods or monthly, this will tell me how much I need now, okay, to the present value. And this is also something that is useful in insurance business and things like that. So if you're finding the present value, I'm using different numbers here. The 2,000 is what you want to have in 3 years. And this 1 plus the interest rate divided by the compounding periods raised to the power is going to give you the amount that you need to invest. So if you've only got 3 years and at 5%, how much do you need to make sure that it's grown to 20,000? You need 17. Okay? Now, in the real world, we put a little bit of money away and a little bit of money and a little bit of money. So the amount in the account is growing every month, plus the interest is being compounded at once a month at the same time. So that's a lot more complicated formula, and it takes calculus. So we don't do that in this class, thank goodness. So to calculate this on your calculator without writing anything down and truncating any decimals is you're going to do the division first. 0.05 divided by 12 times a year. When you hit the plus sign, it's going to calculate that division and add the 1. You have to hit equals after that. Parentheses are the same as an equal sign. So you hit equals and then you raise that to the 36th power because you already figured out what 12 times 3 was. That, when you hit equals, this gives you the value in your denominator. Most calculators have this awesome key. It'll either say 1 over x or x to the minus 1 power. This is going to take that number that's in the bottom and flip it upside down, which is actually going to swing it up to the top. Once you hit this key, the value from the bottom is in the top and you're multiplying at that point. So you multiply times your principal, hit the equals, and that should give you your present value.